Very good morning to everybody. I am Thirumurugan from Sri Vidya Mandir Arts and Science College, Motangarai. So today we discuss about the topic in photoelectric effect. In 1887, Hertz noticed that electrons emitted from the metal surface when electromagnetic radiation falls. In 1888, Halwaj showed experimentally that electrons are emitted from zinc plates when ultraviolet rays fell on the plates. The electrons radiated in this process called photoelectrons, and the current produced in the circuit is called photoelectric current. The photoelectric current in general is a phenomenon exhibited by all these substances and illuminated by the radiation of a suitable wavelength. So the phenomenon of ejection of electron from the surface of metal when light or X-rays suitable frequency strike on it, it is called photoelectric effect. Emitted electrons are called photoelectrons. Are called photoelectrons. It may be noted that cesium, rubidium, and potassium, so negatively charged zinc plate, the minimum energy needed to eject the electron is called threshold energy. The kinetic energy of the electrons is directly proportional to frequency of incident radiation. The kinetic energy of the electrons is independent of the intensity of radiation. So, the emission of electrons independent of the temperature of the metal. Each metal have minimum frequency is called threshold frequency. The incident light below which the number of electrons are emitted. The number of ejected electrons depend upon the intensity of radiation, not for frequency of radiation. It was discovered by Heinrich Hertz. Einstein explained for photoelectric effect. He got Nobel prizes. So we we understood uh, energy of the instant radiation h nu, in which a portion of light used for promote the electron to the outermost surface of the metal. The remaining force of the electrons used for eject the electron from the metal surface. So the energy of the incident radiation is equal to the minimum energy need for eject the electron, that is called threshold energy. The threshold energy is always called as work function. That is the electrons imported to the metal surface. The energy consumed for electron imported to the metal surface, that is called work function or threshold frequency h nu is 0. The work function and kinetic energy of ejector electron will be equal to energy of instant radiation. Therefore, h nu is equal to kinetic energy plus work function equal to energy of instant radiation. So, the kinetic energy of this equation in right hand side, the work function goes to left hand side of this equation. So, we have h nu minus h nu 0 is equal to of mv square. So the kinetic energy is equal to h nu minus s nu 0. We know that h is Planck's constant. The value, know the value 6.626 in 10 to the power minus 34 joule second. So the frequency difference between the instant radiation and consumed radiation work function, consumed radiation or threshold frequency equal to kinetic energy of the electron. So nu is the frequency of the incident radiation and nu zero is the work function of frequency at threshold energy. When the frequency of incident UV light was smaller than specified minimum values known as threshold frequency, then no electrons were emitted at all. The minimum frequency was dependent on the nature of the material of emitter plate. Metals like zinc, cadmium, magnesium, etc. were found to respond only to UV light with short wavelength to cause electron emission from the surface. However, other alkali metals such as lithium, sodium, potassium, cesium, and rubidium were sensitive to visible light. The current produced due to the photoelectric effect is known as photoelectric current. Already said, the kinetic energy of the eject electron is equal to h nu minus s nu 0, where kinetic Ke is the kinetic energy of the photoelectron, h is the Planck constant, v is the frequency of photon, nu 0 is the threshold frequency of the material. Particle nature provide a valid reason for the behavior of matter. So it proves that particles of any matter are always moving, explaining solid, liquid, and gas behavior and properties. So applications of photoelectric effect. Photoelectric effect used in solar cells like as photovoltaic cells and digital cameras, CCD and CMOS sensors, light detectors, Furkler alarm, automatic doors, barcode scanners, etc. So X-ray detectors, medical imaging. So recall that the topic again. Recall that the topic of photoelectric effect when the frequency of incident light was smaller than specified minimum value known as threshold frequency. So the kinetic energy of the electron, kinetic energy of the photoelectrons is equal to frequency of incident radiation. So the kinetic energy of the photoelectron is independent of the intensity of incident radiations. Then the number of electrons depend upon the intensity of incident radiation, not for frequency of the radiation, not for frequency of the radiations. So when we use it only for alkali metals like lithium, sodium, potassium, rubidium, cesium, and negatively charged plate of zinc. So we know that this experiment used for calculate kinetic energy of the eject electron or work function of the material, work function of the material. So number of electrons ejected per unit surface area of the material. So that this effect mostly used in solar cell system and digital cameras and automatic doors and barcode scanners or light detectors and X-ray detectors of medical imaging devices. So, the photoelectric effect is a extension of Compton effect. Photoelectric effect is extended by a Compton effect. When a monochromatic X-rays are allowed to fall on a carbon or some other light element. An electron was ejected and X-rays was scattered at the angle theta had had lambda is larger than the incident light. Lambda is larger than the incident light. So the extension of photoelectric effect, like as Compton effect, when monochromatic X-rays are allowed to fall and the carbon or some other light element, the electrons were ejected, the X-rays was scattered at the particular angle theta, and had a higher wavelength that of the incident radiations. So increase in wavelength, the inelastic collision between the material and X-ray beam, X-ray photons. So we know that the photoelectric effect, the kinetic energy of the electron will be equal to h nu minus h nu 0. At the same way, the energy of the photons of X-ray h nu is equal to h nu dash plus 1 by 2 of m square. In photoelectric effect, we indicated as h nu 0 as the threshold frequency or threshold energy. Here, h nu dash. So the this type of the wavelength difference between the incoherent X-ray scattering is called Compton effect. This type of incoherent X-ray scattering is called Compton effect. The difference between the wavelength of original wave and the scattered wave, the difference between the wavelength of original wave and the scattered wave is called the Compton wavelength. That is lambda dash minus lambda is equal to 2d 2h divided by mc into sine square theta by 2. So we know that sine square theta by 2 is equal to 1 minus cos 2 theta by 2 divided by 2. Therefore, the Compton wavelength or wavelength change of incident and scattering X-rays d lambda is equal to h divided by mc into 1 minus cos theta. The change in wavelength is independent nature of the substance, depend upon the scattering angle only. When scattering angle is theta is equal to 0 degree, the del lambda is equal to 0. The Compton wavelength always 0. When the scattered radiation is parallel to the incident radiation, there is no wavelength shift. The del lambda is equal to 0 means there is no change in wavelength shift. When theta is equal to 90 degree, del lambda is equal to h divided by mc into 1 minus cos theta. Theta is 90 degree, 1 minus 1 cos theta 90 degree is equal to 0. So h divided by mc into 1. So this means the incident X-rays and scatter radiation are perpendicular to each other. Then theta is equal to 180 degree. Theta is equal to 180 degree. Del lambda is equal to h divided by mc. The cos 180 degree is equal to minus 1. So 1 minus 1, 1 minus 1, 1 minus 1 is 1 plus 1. 2. Therefore 2h divided by mc. That twice amount of wavelength difference for the Compton wavelength of 2h divided by mc. This twice the value of the Compton wavelength. The minimum Compton shift occur when there is no scattering. The maximum Compton shift occur when the photon is scattered. When the photon is scattered about 180 degree, the value of del lambda is equal to 2 lambda 0. So the extension of photoelectric effect, the modification of photoelectric effect explained by Compton effect. So the modification, the ejection of electron from the metal surface in photoelectric effect. Now here, the X-ray are scattered in different angles, like as theta is equal to 0 and theta is equal to 90 degree and theta is equal to 180 degree. The wavelength difference between the incident X-ray and scattered X-ray is called Compton wavelength. The coherent of wavelength changer is called Compton effect. Right? So I feel could you understand in this video. So thank you for your watching. Thank you.